Hello viewers, I am Kausalya. Today we are going to see the derivation of response of second order system for underdamped case and when the input is unit step. So what is a second order system? It is the system whose denominator polynomial has a maximum power of 2. As the maximum power of denominator polynomial is 2, we are naming this one as a second order system. Right. Then what is meant by an underdamped case? So in the case of underdamped one, the damping ratio, that is this zeta value, lies between 0 and 1. And what is the type of input here? Here the input is step input. Now let's see the standard form of a closed loop transfer function. So it is given as C of s by R of s is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. Now what is the type of input here? We are feeding this one with a unit step input. So for unit step input, the value of R of s is equal to 1 by s. Here C of s is your output and R of s is your input. In the next step, I am moving this R of s to the right hand side. So C of s is equal to R of s into this term omega n square by s square plus 2 zeta omega ns plus omega n square. Now substitute the value of R of s as 1 by s. Right. The next step is we are going to solve this expression. So the only way to solve the above expression is by using partial fraction method. So in case of partial fraction, you see here the denominator has one s term and one quadratic equation. So for s term it is easy, we can simply write it with some alphabet. So a by s plus, since as we are having quadratic equation here, we have to write it as bs plus c. That is, the numerator part should also consist of two terms. So we are writing it as bs plus c. The next step is we are going to take LCM. So when you take LCM here, that just we can cross multiply. So a into this expression plus bs plus c into this s, and denominator term, these two terms will combine. Right. So here in this case, both the denominator terms are same. So these terms will cancel each other. And finally, the remaining term will consist of omega n square is equal to this one, right? So this is the respective expression. Our next step is we have to find out the values of A, B and C. So to find out the value of A, first I am substituting the value of S is equal to 0. So when you substitute S is equal to 0, you see this term reduces to 0, this term reduces to 0, and here we are having s. So 0 multiplied by anything will become 0. So the only available term is a into omega n square. Right. So here again this omega n square and this omega n square cancel each other and the value of a will be equal to 1. Right. And the next step is just here I had multiplied this expression. That is, I have multiplied a with this part and s with this part. So when you multiply, what will happen? A into s square, here as square. So a into 2 zeta omega ns gives 2 zeta omega ns into a. Plus again a into omega n square gives omega n square a. Again plus, here plus, just multiply s into bs gives bs square plus s into c gives sc. Right. Next thing is equating coefficient of s square. So now we are equating the coefficient of s square. So here I am having this term a into s square and again b into s square. So what is the coefficient? Coefficient of this s square is a and this s square is b. So a and this b is with the positive sign, right? So a plus b, okay, this forms your right hand side. And when you look at your left hand side, there is no s square term. So here I am writing it as 0. So 0 equal to a plus b, and we already know the value of a. So just substitute the value of a here, and finally the value of b is found. B is equal to minus 1. Right. And the next thing is equating coefficient of s. So here this is your s term and here this is your s term. So now equate the coefficients. You will be having 2 zeta omega n into a, and here the value of a is 1. We had already find out this one, right? And the next one plus the coefficient of s is c here, so plus c. So from this equation the value of c is found to be minus 2 zeta omega n, right? Now we are going to substitute the values of a, b and c. So when you substitute the values here, what happens? The expression becomes like this, 1 by s plus, for the value in the place of b we will be having minus 1, so minus s, and the place of c I am having 2 zeta omega n, so here 2 zeta omega n, right? So here in this expression we are having minus in both the terms, so I am taking this minus term outside. So when you take minus outside, this expression becomes s plus 2 zeta omega n, and the remaining terms as such, right? Now the next step is adding and subtracting zeta square omega n square to the second term of the denominator, right? And here, so c of s is equal to the first term as such minus, to this denominator term we are adding plus zeta square omega n square minus zeta square omega n square, right? And the next thing is, you see I am combining this one and this one. That is, I have taken this term and this term together. And the remaining term will be omega n square minus zeta square omega n square, right? And the next thing, when you observe this carefully, we can reduce this expression as s plus zeta omega n whole square. Look, a plus b whole square. So a square, in the place of a I am having s, and the place of b I am having zeta omega n. So s square plus zeta square omega n square b square and plus 2ab. So 2 zeta omega n into s, right? So this term gets reduced as s plus zeta omega n whole square plus, and when you consider this term, here omega n square is common. So when omega n square is taken, the remaining term will be 1 minus zeta square, right? And the next thing is 1 by s minus, here the remaining things I am writing as such, and here this entire expression I am writing it as omega d square. This is as per the formula. That is, this omega d is nothing but omega n into root of 1 minus zeta square. That is the formula. So here simply I am replacing this expression with omega d square. And here again now I am splitting the numerator part, that is plus 2 zeta omega n can be written as plus zeta omega n and plus zeta omega n, right? Here 2 is written as 1 plus 1. And the next thing is I am splitting the denominator term and I am writing. So here you see s plus zeta omega n is taken as one term divided by this denominator term as such, and again here this zeta omega n is taken separately. So here minus into plus becomes minus. So minus zeta omega n divided by this denominator term, right? So this is our respective expression here. Now again we are doing multiplying and dividing third term by omega d. So in this expression this is our third term. So I am multiplying and dividing with omega d. So you see omega d, here I am multiplying and here I am dividing. After doing this, we are moving to our final step. We are taking inverse Laplace transform. So when you take inverse Laplace transform for this expression, so inverse Laplace transform of c of s is equal to again inverse Laplace transform of this entire expression, right? And the next thing is inverse Laplace of 1 by s becomes 1 and this minus as such here, and for this the formula is we are having s plus some extra terms here. So e power minus zeta omega n t, and for this remaining term cos omega dt. This is the respective formula. Minus, I am writing this expression as such here, And here the remaining term is e power minus zeta omega nt into sine omega dt. Here the respective formulas are written. And the next step is, when you look carefully, here zeta omega nt and here also e power minus zeta omega nt, the terms are common. So I am taking e power minus zeta omega nt outside. So the remaining expression will be cos omega dt. As I am taking minus term outside, here this minus becomes plus here. And zeta omega n, and I already said omega d formula is omega n into square root of 1 minus zeta square into this sine omega dt as such. And the next thing is, I am taking LCM. So when you take LCM, here the denominator is square root of 1 minus zeta square. So then this expression becomes just, I am multiplying this with this term. So cos omega dt into square root of 1 minus zeta square plus del into sine omega dt, the whole term divided by square root of 1 minus zeta square. So now this square root of this denominator term I am taking outside. So e power minus zeta omega nt divided by this square root of 1 minus zeta square. And here you see this square root of 1 minus zeta square, this one and this zeta terms or get replaced by theta. I will explain you how. So here just I have rewritten this expression. This term I had written first and this term I had written next. Right. The next thing is, I am going to replace this zeta and square root of 1 minus zeta square by theta. I will explain you how. So here you see, consider this triangle. Okay, I am constructing a triangle with zeta and square root of 1 minus zeta square as sides. So when you construct a triangle like this, its the hypotenuse value becomes 1. So this is a right angle triangle, right? So this is a right angle triangle. So from this right angle triangle, I am finding the values of cos theta, sin theta and tan theta. So cos theta, the formula is adjacent side by hypotenuse. So you see, this is your theta. So this is your adjacent side and this is your hypotenuse. So zeta by 1, which is equal to zeta. And the next one is sin theta. So here the sin theta, the formula is opposite by hypotenuse. So here the opposite is square root of 1 minus zeta square and the hypotenuse term is 1. So sin theta is equal to square root of 1 minus zeta square. And the next one is tan theta. So tan theta is opposite by adjacent side. So here for this theta, this is your opposite side and this is your adjacent side. Just substitute the respective values. And finally here, theta, when you want theta, you can just move this tan to this side. So when tan is moved this side, tan becomes tan inverse. So tan inverse of square root of 1 minus zeta square by zeta. Right. So here, I had written in the place of zeta, that is in the place of zeta I had written cos theta, and again in the place of square root of 1 minus zeta square I had written sin theta. Right. So finally, when you reduce this expression, this is equal to sin a plus b, that is sin of, here in the place of a I am having this omega dt and the place of b I am having theta. So sin of omega dt plus theta. So this is our final expression, that is this is the output response of a second order case. And here where the value of theta can be written as tan inverse of square root of 1 minus zeta square by zeta. These terms we had already found out here. And here this is your final output. So from the final output, what do you observe here? That is, this system will consist of oscillations, right? This system consists of oscillations, but what about the type of oscillations, whether it is increasing or decreasing? Here the oscillation level gets decreased gradually and finally the system gets settled down, right? So this is clearly observed from this diagram. We had come to the end of this video. Hope you people understand the concept. Thank you.